So welcome to quite potentially our last help video on 3B7. We may have broken the record for the most help videos over any assignment ever in the history of education. If we did, that's great. But it is important. You can always tell how important an assignment is by how many help videos are associated with it. All right, we're starting off with questions 51 through, I guess it's 55 in this particular section. Let's take a look. We have an atom drawn here. The atom looks like it has 1, 2 electrons on this level. 1, 2, 3, 4, 5, 6 on that level. All right, so the second level is not full. On that second level, they would like to have 8. That second level holds 8. The octet rule says all levels except the first level need to have 8 for stability purposes. Let's take a look at what's in the nucleus. There's 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8 protons. There is 1, 2, 3, 4, 5, 6, 7 neutrons. So there's 8 protons and 7 neutrons in the nucleus. There are 15 total particles in the nucleus. So the mass number of this thing is 15. There are 15 nucleons. The atomic number of this thing is 8. There are 8 protons. We also counted 8 electrons. So this atom is not charged. The atom would be chemically stable if it became 2-. I guess we didn't have to count a whole lot to answer that one because there's 6 here, and that level holds 8. It would need 2 more to fill that level to satisfy the octet rule. That's true. The nucleus is most likely unstable, as another neutron would be needed to stabilize it. Well, we've already hinted at the fact that the smaller atoms do best when there's 1 proton for every 1 neutron. And in fact, it was okay on a lot of the atoms we saw to have 1 more total neutron than proton. But if you had much more than 1 neutron more than the protons, the nucleus became unstable. So on this particular atom, we have 8 protons and only 7 neutrons. So it is most likely unstable. Another neutron would help stabilize it. The hyphen notation for the diagram above would be oxygen hyphen 15. Remember, hyphen notation, you can give the symbol hyphen or you can give the name written out hyphen. And what goes after the hyphen is the mass number, the total number of particles in the nucleus, which can differ from isotope to isotope. That is why they report that. They don't have to tell us anything about atomic number because they told us it was oxygen. When you use hyphen notation, they are assuming that you have a periodic table to look at. Here's oxygen. There should be 8 protons in the nucleus for it to be oxygen. With that in mind, we know the oxygen part is right because there's 8 protons. The hyphen part is expressed correctly. And then the fact that there's 15 particles in the nucleus, 15 nucleons is expressed correctly. That's true, 53. 54, the atom in the diagram would be found in column 6. Well, there's 6 electrons in its outermost level or valence level. We know the Roman numerals on the periodic table correspond to the number of electrons in the valence. So we would expect it to be 6, but let's double check. There are 8 protons, so we know that this element or this atom belongs to the element oxygen. The Roman numerals were on the ion one. So let's find oxygen. Number 8, there it is, group 16, which means it's the 16th group from the left. That's the group number. But we go to the top, there's the Roman 6. Yes, it should be Roman 6. Why? Roman 6 means there's 6 electrons. 2 more would be needed. That's why there's a 2- here. 2 more would be needed to add to those 6 to get a Roman numeral 8 total. 54 would be true. 55, the nuclear symbol would be represented with a 15 in the upper left and an 8 beneath it. Oh yeah. The 15 is the mass number, the total number of nucleons or particles in the nucleus. That's what by definition or convention when we're writing nuclear symbols. The total particles in the nucleus, the mass number represented by the symbol A goes here. The atomic number is in the lower left when we write it in nuclear symbol format. Here's oxygen's picture from the periodic table. There's an 8 in the upper left-hand corner here. Why? Because on the periodic table, the 8 can go anywhere. There's not a rule where it has to go. And in fact, the 15 goes nowhere on the periodic table because this atom has 15 in the nucleus. Some atoms of oxygen have 16. Others might have 17, some 18. Maybe other numbers are possible. Because how many things an atom has in the nucleus depends on how many neutrons it has, and neutrons can vary from atom to atom for a particular element. The 8 can't vary. That's why the 8 must be there. So this is indeed the proper nuclear symbol format. And now for our final group of questions. Some anion. Anion is a negative ion. An N right in the middle of the word. A negative ion. Has a charge of 3 minus. An atomic number of 33. When they're telling us the atomic number of 33, they just told us who it was. If you look on the periodic table of elements, an atomic number of 33 is arsenic. And arsenic, in fact, likes to be 3 minus, as it says here, the same as it says right here. So we know it's arsenic. If you don't believe me, we could look on a regular periodic table. There's arsenic, 33. So what do we know now about this thing? We know that it has 33 protons. We also know how many electrons it has because the protons are positive and it's 3 minus. There must be 3 more negatives than there are positives. So it would have 36 negatives. And they also told us that their mass number is 75, which means it has 75 particles in the nucleus. 75 are nucleons, and 33 of them are protons. So there's 75 total particles in the nucleus, and 33 of them are protons. 75 minus 33, 42 of them must be neutrons. Let's go on these questions here. The anion has 36 electrons. Absolutely. If it has 33 protons, positive particles, and it's 3 minus, then there must be 3 more minuses than there are positives. 33 and 3 is 36. 33 and 3 is 36. So here's how many positives it has. That's 36. If it has 36 negatives, then it would be neutral. It must have 3 more negatives than positives for it to be negative. So there must be 36 negatives. And that's what it says right here. 33 plus 3 is 36. 33 minus 36 is 3 minus. If you have 3 more negatives, 36 negatives, then you do positives 33. The overall charge is 3 minus. 3 negatives. 56 is true. 57, this anion would have 42 neutrons. Well, if there's 75 total particles in the nucleus, and 33 of the particles are protons, 42 of them must be neutrons. Mass number, which is right here, 75 nucleons, that's the mass number. Nucleons are the particles in the nucleus. That's what the mass number tells you. The mass number is 75. The atomic number is 33. They told us right there, 75 minus 33, 42 neutrons. That is true. An isotope could have the isotope could have a hyphen notation of arsenic 74. Well, we know isotopes have same atomic number, but different mass number. If this one has a mass number of 75, an isotope of it would have a different number other than 75 after the hyphen. So again, we knew it was arsenic. We knew it was arsenic. We knew arsenic right away when they told us 33. We just looked on a periodic table with 33. So the name or symbol could go here. We could put an AS for arsenic hyphen 74. They wrote it out. Arsenic hyphen 74. 74 is a different number than 75. That's true. We just need a different number there. Both arsenic 74 and arsenic 75, this one would be arsenic 75 up here, have 33 atomic number. But arsenic 75 has 42 neutrons. Arsenic 74 has 41 neutrons. Isotopes have different numbers of neutrons, same number of protons. Based on the charge of the atom, we would suspect it could be in family 5. Absolutely, family 5 needs 3 to get 8. Let's verify. Here's arsenic 33. It's group 14. The group numbers go left to right. 1 through 18 because there's 18 vertical columns. But we go from arsenic to the top of the table, up here. It is in Roman 5. Why? It needs 3 more to fill its outermost level, to fill its valence level to get 8. If arsenic gets 3 more, 1, 2, 3, it would be stable chemically like krypton, who has 36 electrons and has filled its outer level with 8. All right, our final question, number 60. The nuclear symbol would be 75 in the upper left. Sure, it would be 75 in the upper left because it has 75 for its mass number. 75 particles in the nucleus. That's what goes in the upper left. In the lower left is the atomic number. They told us right out of the gate that the atomic number was 33. That goes in the lower left. We had to look on the periodic table to see that anything with an atomic number of 33 is arsenic. And we know that the atom is 3 minus because they told us the atom was 3 minus right up here. So when they tell you you have an anion, this would be arsenide ion. The negative ions, you change the ending to I. Arsenic would become arsenide when it's 3 minus. In the nuclear symbol format, you put the charge, if there is one, after the symbol. So they did the correct nuclear symbol right there. This is the conclusion of the help videos for 3B7. If your questions were not answered, do not hesitate to ask, because this is a huge assignment to understand for your success in the subject of chemistry. Thanks for watching.